when I'm riding around the globe, and I'm doing this and I'm signing.
Hi guys, my name is Nako Nakatsuka. I'm a fourth year chemistry PhD student at UCLA, and today I'll be helping you guys out by going over some general chemistry concepts. And good luck with the course. So we'll start by talking about thermochemistry, and this is the study of heat released or absorbed in chemical reactions and physical changes. And so, for example, glucose is our major energy-giving carbohydrate, and it's converted to carbon dioxide and water by a series of enzymatic steps. And so the overall reaction can be written as C6H12O6, which is glucose, plus 6 oxygen, going to 6 carbon dioxides and 6 waters. So this is a really typical example of an overall chemical change. And the heat given off in this chemical reaction gives us the ability to do work. And so it gives off heat, and in turn, it lets us do work. So when you take in carbohydrates, when you eat something, it gives us the energy that allows us to do things, right? And so each beat of the human heart uses approximately 1 joule, or 0.24 calories. So that's why we have to continuously eat during the day or we get really tired, because we need to give energy to the different parts of our body that does different work. Okay, so the amount of heat released or absorbed at a constant pressure is called enthalpy. And we'll go over all of these individual components in more detail later. But enthalpy is QP at constant pressure. What this means is that delta H is enthalpy, and the amount of heat released or absorbed at a constant pressure, where this subscript P represents constant pressure, and Q is the letter given to heat. So I'm introducing you to all of these different terms that you're going to have to use a lot in thermochemistry. Okay, and also if a reaction gives a net release of heat, the reaction is called exothermic. So exothermic is when a reaction releases heat. And what this means is that it has a negative delta H or enthalpy value. This also means that when you have an exothermic reaction, since the reaction releases heat, the surroundings get warmer. Okay, so the other reaction is called endothermic. So this is a reaction that requires heat. And so as you can guess, it's actually the opposite delta H or enthalpy value, since heat is moving in the opposite direction. So it's positive now. And so since the reaction requires heat, the surroundings actually end up getting cooler because it takes up heat. So enthalpy is also known as a state property. What that means is that the value of enthalpy is determined by its current state, and it's not dependent on the path taken to obtain that state. And so let me abbreviate that here for you. This is determined by current state and not by the path. So state properties can also be added and subtracted. And so what that means is that the change in the enthalpy value, since delta indicates change, is a result of the enthalpy value of the products minus the enthalpy value of the reactants. And this is because it's a state property. and it's determined by the current state and not by the path it takes. So other state properties that I'm going to briefly mention here are things such as internal energy, and don't worry, we'll talk more in detail about these individual properties later on. Also pressure, volume, temperature, density, which remember is mass over volume, and also heat capacity, which again we'll talk about in greater detail later, so don't worry about it just yet. I just wanted to show you a list of other state properties. So on the other hand, work and heat which we gave the letter Q, does depend on the path taken. So it makes it not a state property, and it is called a On the other hand, when we talk about work and heat, which I told you before has the letter Q, these actually depend on the path taken and not on state properties. So these are actually called path functions or path properties. So here I talk about the difference between state function or state properties and path functions or path properties. And it's determined by whether or not it depends on the path taken to get a certain value.
On the globe, and I'm doing this, and I'm signing that.